right. Hello, everyone. As you can see up there, my name is Shawn Anderson. I work with Emerson, specifically with the Fisher Flow Controls division. So that's the group that's responsible for developing and making control valves. So we do control valve systems, and my specific role is actually in a kind of a research function. Was that me or you? Okay. And what we're working on is really a lot of the bringing IoT to control valves. And the way that we're doing that is looking at next generation diagnostics and prognostics and how we couple those with some of our smart instruments in order to make kind of an IoT pathway for a lot of our customers. And I'll show you through some of the slides that there's definitely some challenges to overcome in getting to that. But again, so while a lot of the things I show here in the slides are things that we're doing today that are commercially available, some of the things that our group is working on is actually kind of the next generation of these things and how we'll continue to evolve those in the future. So just for anybody that's not familiar, Fisher is a industry-leading control valve manufacturer. We make control valve equipment for lots of different industries, specifically the energy sectors like oil and gas and power, but we also get into pulp and paper, metals and mining, food and beverage, pharmaceutical, all those different types of things. Traditionally, we're thought of as kind of a pig iron company. We make really big valves and actuators, and that's what controls your process. But more recently, especially in the last 25, 30 years, a lot of the focus has been actually on the instrument. So these little devices here, you'll probably hear me call those positioners, DVCs, digital valve controllers. All those things are basically interchangeable. But a lot of smarts are being built into those devices, and that for a control valve is really the gateway to getting some information and looking at control valve health. And so that's kind of the focus on some of the things that we're talking about. So the Fisher DVC kind of hit the market in the mid to late 90s, and the adoption picked up a lot more probably after 2000. But what that did is it actually put some sensors on the valve and added connectivity to the valve and communication capabilities. And I would say that almost from the onset of us providing digital valve controllers to the field, we kind of had this idea of IoT in mind, maybe even before that was a term. But I'd say just in the last handful of years, the technology has kind of caught up enough to a point to actually allow us to do that and actually provide those as products and services for our customers. So some of the drivers, the big thing is IoT growth. And if I just say IoT, we're all familiar with that from a commercial standpoint. Commercial products, things that we use around the home in our daily lives. But that's also starting to trickle into the industrial industries as well. And so there's a lot of initiatives out there for using connected devices, looking at monitoring and predictive maintenance. The other big thing is just smart devices in general. As I mentioned, our DVCs have been smart for 25 years plus, but continue to get smarter all the time through firmware changes, hardware changes, and associated instrumentation that can go along with the device. Another big deal is sensors. Sensors are really evolving. They're getting smaller, more powerful. They don't take much energy. They can run on batteries. And the ability for us to add additional sensors is a big deal. Because, right now in the current environment, we have sensors inside the digital valve controller that can do some diagnostics and some health monitoring. But it's also perceivable now that we could start adding additional sensors on or around the valve to give us a bigger picture of the health of the valve, maybe even the process, or keep going up through the unit and through the plant and the enterprise. So the cost is getting very attractive for being able to add extra sensors to valves or associated products. And when I'm talking about sensors there, Emerson makes a lot of different sensors, transmitters, transducers that are used on the control side, but there's a big opportunity for a lot more sensors that are more for monitoring and diagnostics and not necessarily a key part of the control. Some of the other big drivers are, the cloud-based solutions that are now available. A lot of the big players are starting to provide solutions there that enable a lot of this type of functionality. And just the data that's available or could be available is also a really big driver. I would actually contend that for control valves, the data has been available for a very long time. It's just that it wasn't easy to visualize, wasn't in the right context, or wasn't combined in a way that somebody could really make good sense out of it. So the data's been there, but that's been one of the big drivers for us lately, working with some partners such as Seek to be able to put that data in a proper visual format, to apply the right context and really enable our subject matter experts to do something with it. And then the better we get at enabling our subject matter experts to do things and to figure out ways of identifying problems early, we can start to automate that, and it's just a continuous cycle. So that's really been a big benefit for us working with Seek here recently, is being able to do that. So some of the challenges faced by our customers, by the end users, is, and I think Ralph talked about this a little bit earlier, there's an extreme focus on reliability, availability, and uptime. They just cannot afford to have the plant not running, not operating, not producing products. So, obviously a really big driver. And one of the issues is that a lot of times, maintenance is reactive instead of being predictive or proactive, and there's huge advantages to being able to predict and plan a maintenance or outage period instead of waiting till something fails and then try to fix it quickly. Another big challenge faced by a lot of our customers is the fact that, like any organization, they try to run as thin as possible. They don't have the number of people that they used to have, and they're also spread pretty thin. So a lot of times, even though we think we're providing them with some great software tools, such as our ValveLink software and other tools, they just don't really get a chance to develop the core expertise to really utilize that technology fully. And that applies to, not only the diagnostics, but trying to predict how long that valve is going to last, when it's going to need repair, things like that. So, a lot of our customers see the value in it. They pay extra for devices that have the functionality. Sometimes they pay for upgrades and software that has that functionality, but they often struggle to get the whole value out of it. And so that's obviously a motivator for us to try and improve that as well. And then if we start to look at the diagnostics and the predictive technologies that we're working on, we've got to be careful not to actually increase the complexity, because if it's already an issue, we need to try and make it easier. And everybody talks about turning data into actionable information. That's really what we got to get to. If we come up and tell our customer that his friction is 250 pounds, a lot of times they'll say, is that good or bad? We need to tell them, not that your friction is 250 pounds, but your packing is failing, you need to replace your packing. Those are the types of things that we have to get to. And then, the other thing, just technology always has the ability to add some risk to some of this as well. So we needed to make sure that the technology we provide actually solves some problems instead of making them a little bit more difficult or complex. Another key thing, there's a lot of advantages to trying to connect some of our subject matter experts, some of the people that we have internal, with our customers. We've got folks in our service organization especially that have been out there diagnosing, repairing, fixing control valves for 15, 20, 30 years, and they've got a ton of knowledge. But our long-term service paradigm is, you send a person in a truck with some tools out and they go fix a valve. And we would really like to get to a point where those same people that have all that experience can actually see the data without going on site. It allows them to be a lot more efficient. They can make sure they got the right tools, the right parts. They know what they're getting into when they get on site, and that's a big deal. So there's a lot of advantages to bringing IoT to control valves, but there's a lot of hurdles, a lot of barriers there. Things like security and reliability are always big deals that we have to deal with. But one of the biggest ones is that, just the connectivity in general is really pretty tough in a lot of cases. Our valves sit down here at these low levels of the control network. There's typically either no remote internet access, or it's very, very, very limited. And so there's definitely some hurdles that we have to overcome there as far as getting the data and being able to act on it remotely. And that opens the door for us also, though, as Ralph alluded to doing some more of the computing, some of the analysis right in the field. So it could be at the devices, could be edge computing, could be on site of some form. But we think there's a lot of advantage to getting that remote connection as well. So from the end user perspective, we're starting to see a lot more acceptance of IoT type functionality in the process industries. As most of you are aware, sometimes we're kind of slow moving in these industries to adopt new technologies, but I think people are really starting to understand the benefits, and also to be able to understand that they can take advantage of our remote experts when they maybe don't have those, and so that's obviously an opportunity for us to provide those services. So getting that link established where the on-site people and our experts can collaborate remotely and then better plan their outage or their maintenance has a lot of advantages. There's the obvious concerns that we got to deal with about security that we've already talked about, but one of the big ones is ROI. Like I mentioned, we sell products that cost more because they have diagnostic capabilities and sensors. Same with software and services and things like that. But at the end of the day, the customer needs to feel like they actually got something for that investment. And honestly, a lot of our customers buy some of that stuff from us today. Because they see the vision, but they struggle to fully implement it. And that's what I think we got to really be able to help them out with in our next generation offerings. The other thing is local expertise. We talk about a remote monitoring solution and maybe some edge computing or on-site computing, but in some cases, the end users or the customers want to have some visibility to this analytics or these platforms as well. And so there's probably some hybrid solutions in there too, where maybe an on-site expert that is internal to the company might want to look at some of this information, and maybe they want to do a deep dive into the data analysis, maybe they don't, but they should get some high-level overview of what's going on with the valve, but then have that ability to communicate or collaborate with a remote expert when they need be. So those are all types of things that we're looking at as well. So in the last couple of years, Emerson has launched some connected services offerings, and for valves, I would say it's about the last year and a half or so that we've been doing this. We've actually been doing it a little bit longer from a pilot phase. So within our research, we've been monitoring a handful of sites that are local to our facility, trying to develop this. But we've had some pretty good success so far. I'd say it's still in its infancy, it's still growing, lots of room for improvement, but it seems to be showing some good growth potential. And I'll talk a little bit more here in a couple slides about how that data flow works. But today's paradigm is getting some data from the customer site, getting it in front of an analyst, putting it in the right context, and then allowing them to provide feedback through, say, a monthly report to the end user. And both from the commercial side and also from our research side, we are starting to address and realize, some of these concerns with ROI and security and how we move the data around. So we're constantly learning, constantly getting better, and I think you'll see some big changes in that here, especially in the next year or two. So I want to show you a couple examples, and some of these are fairly generic, but they are real. Just kind of want to show you some of the things that we can do with some relatively simple data that is already there and available, but maybe not put in the appropriate context to be able to let somebody make a good decision. And in some cases, that somebody might even be the subject matter expert. In the past, sometimes they've struggled to combine data in the right context to be able to make a good call. And so that's some of what we're doing. And as we're going through this, you might say, that seems pretty simple, but in some cases, we just didn't have the ability to do that before because some of our legacy software products or platforms just weren't built with that type of functionality in mind. And again, that's some of the things that our partners at Seek have really been able to help us out with. So what I got here, and these are going to be eye charts, they're going to be hard to read, but combining data sets that weren't easily done before is important. We've got online data that we can collect with our ValveLink software, and it can show you parameters trended over time and lots of different ways of looking at that data. But you can't always just pick and choose which data sets you want to look at. You can't say, well, show me this parameter and this parameter if they're not part of a standard test or diagnostic already. So sometimes that's a limiting factor, and our analysts struggle to tie all these different parameters together if it's not presented properly. So one of the things that we've done is got this ability to let the analyst say, well, I want to look at this set of parameters regardless of where they came from. We'll overlay them in time and maybe see if there's any correlations that might not have been apparent before. So what we're looking at here in this top green graph is friction, online friction calculation for a valve. The blue Actually, it's hard to see, but there's a blue and kind of magenta line almost laid right on top of each other here. And those are the travel ranges when that data was being collected. So, if you think about a normal throttling valve, it doesn't move much. It might be 0.1% or something on that scale. But you can see that this valve isn't moving a lot in amplitude, but it is moving around, and we're able to calculate friction live on the fly while we're doing that. So it kind of shows the operating range of the valve and the friction level. And one thing that might be noticed is that I kind of zoomed in on this to make it a little bit easier to see, but friction was down at this level for a while and returned down to about the same level, but there was some period of time where that friction level was higher. Good information, but the real issue is, why was it higher? That's what everybody wants to know about. Well, something that we couldn't do in ValveLink before was to overlay the device temperature on top of that. Device temperature might seem kind of strange, but a lot of times it pretty closely tracks the temperature of the valve because of where it's mounted. So if valve temperature increases, you'll see the device temperature increase a little bit. And you can see that increase in temperature right there correlates to that increase in friction. And so, being able to take pretty simple data sets that already exist, but overlay them in time, kind of gives us an indication that, maybe we're seeing a friction increase because of a temperature increase in the process, which could be related to thermal expansion or some kind of buildup in the valve or some other number of things. So just being able to correlate data sets that are pretty simple but wasn't very easy before is a big deal. If you go back a few years ago, for somebody to be able to do this would mean, probably exporting some data sets out, converting the file formats, trying to put it in Excel and make a graph. And, this graph that just pops up might have taken them an hour to really put it into the right context and figure out. Another example is, sometimes you go into operating plants or units and there's a handful of valves that are all doing the exact same thing. And that's a really, really big opportunity for us to provide some analytic capabilities. Because say you got 6 new valves, they're all doing the exact same function and supposed to be behaving the same way. It's really easy to start taking those performance parameters and overlaying them and seeing if they're all behaving the same way. So the things that you can learn from that is, okay, of my 6 valves, is there one that's responding slower? That might be important. Is there 2 or 3 of them that are faster than the others, and maybe there's some optimization things that could happen there. There's a lot of things that we could look at just by being able to take these functions and overlay them on themselves to see if that valve is changing by itself over time, or if all these valves are behaving the same way as the other ones should be. Some of the things that we've done with Seek here recently is we've taken this online data, and it's hard to tell from this graph, but these valves are actually doing full strokes, like on a PSA skid or a molecular sieve or something like that, and they're supposed to do the exact same thing every single time. So we can go in there and we could either visually overlay the graphs and see if all these responses are the same, or we could just calculate response times up and response times down, and then we can say, okay, all these valves are stroking in 4 seconds. We got one that's stroking in 6 seconds. That's an issue. We should probably look at that valve. And then just simple time series trends and analytics can also be pretty valuable as well. So this one here is actually looking at supply pressure to a device. And you'll see that it's pretty flat up here. You'll see these vertical spikes every now and then. And what happens there is, if the valve has a demand to make a pretty good size movement, it'll locally pull that supply pressure down just for a fraction of a second, but then it'll recover again. And you can see, in general, it was responding about here. And then over the course of maybe a few weeks right here, we're starting to see some decay in supply pressure. So there's a lot of things that could cause that, but at some point that'll start to cause a performance or reliability issue for the valve. It could mean the valve won't go fully shut, could mean the valve can't go fully open or respond as fast as it used to be able to. But being able to pick up those changes, there's typically some overhead in supply pressure settings, and so if you can start to see that decaying ahead of time, you could probably get that adjusted without any downtime or minimal downtime. And in a lot of cases, this might be something simple like somebody bumped a valve upstream, or you got some flexible tubing that's being melted, or there's some kind of plugging in the regulator. A lot of times this might be a $100 fix on a $20,000 control valve, but if it's not addressed, it can take the whole process down and cost a lot more than the cost of that valve. So I want to talk a little bit about the flow of data, and we'll kind of talk about it in three different time frames. If you go back, say, a couple years ago before we started offering any kind of a connected services offering, it was pretty difficult to do anything besides reactive maintenance in a lot of cases. Valve would break, like Ralph mentioned. They call up the Fisher service guy, and we send somebody out and we try and get it fixed, and we get there and we realize, oh, it's a different part that's broken. We need to order that, and things can just snowball from there. But if you're trying to do that from a predictive standpoint, there's sensors and information. Got some device software that can go out and collect data. And let's say the end user, the customer, something doesn't seem quite right. He can't tell what the problem is. Maybe not be a problem, but not sure. He might run a little bit of data collection here, and then probably has to get a hold of somebody and say, hey, I'm going to send this to the Fisher or the Emerson sales channel and see if they can help me with it. That person will probably is probably an outside salesperson and has to contact an inside salesperson who will probably send it back to a sales support person at Fisher, who will go to an expert, possibly in our group or in their service group, to get some help. And there's a long cycle there, and if this is done on email, it can take days or weeks just to get an answer. It does happen, and we do a lot of that today, but just the nature of communications and how it's happened or how it gets handled can add a lot of lag time to that. So there's a ton of room for improvement on that. With our current connected services offering, and again, I'll admit that we're starting out kind of slow because the architecture, the infrastructure isn't there to provide full IoT support right off the bat, which we are working on. But what we do now is we set up this software to collect data on a regular basis. It's scheduled, collecting as often as we can. We use kind of a procedure with the customer to make sure that the data is being collected, verify that it's being collected, and we kind of have to do a sneaker net model in some cases if there's no connectivity already in place. So that means that they collect this data, they generate a file, and then probably take it off on a thumb drive over to a computer at their desk where they can do some kind of a large file transfer and send that up to the cloud. And once it gets there, then our analysts will look at it using tools like our ValveLink and Seek, and then they can do the analysis. So there's a little bit of lag time, but it's generally measured on the order of hours or maybe days. Way better than what we talked about before. So that's kind of the current model, and it seems to be working, but there's a lot of advantages and benefits to trying to fix this air-gapped solution right here today. And so we're working on both hardware and software solutions to be able to handle that. But in addition to just this data flow, there's also the possibility that our devices will get smarter. We'll run some of these analytics there. Our software will get smarter. And then we would probably have some edge computing, possibly through a Seek interface somewhere in this area that could also do some data analytics. And that data analytics would not only include valve information, but hopefully other data sources as well. And you can imagine, other data sources could be new sensors that we put there, or data sources that are already there that we just haven't really connected to in the past. So ideally, what that would look like is, end user has the data, and again, today it's kind of the sneaker net model, but if you can imagine this being a more automated data transfer, then our analysts would look at the data, hopefully with more and more automation as things improve over time, and then they have the ability to either send the analysis to our sales channel for communication back to the customer, which is kind of the normal method, and that's kind of the method that assumes that nothing's broken or in dire need of repair. But if something does look, like it could fail soon or could be a big deal, they also have the ability to get right back to the end user and kind of short circuit this extra lag that you might introduce into the process. So that's kind of the current model that we're working on there is kind of a regular routine reporting structure, but also the ability to make it quick if we need to, because sometimes things like that do happen. So some of the benefits to the end user, is and this is also a huge benefit for Fisher and Emerson as well, is getting our customers to really realize the value that they get from these smart instruments and the software platforms that we provide. A big deal is just collecting the data more frequently. Our devices have had the ability to collect a lot of data for many years, but it amazes me how many times I can go out into a customer site that's had those devices for a long time and there's like 0 data sets in them. It just doesn't happen. So part of this is us forcing that, that device to go out and start collecting the information. The expert analysts are constantly applying new methods or learning new methods to do valve health assessments. Traditionally our analysts would go out and run offline diagnostics during an outage, which is great, but it's almost too late in some cases there if you find a big deal to round up parts and get it repaired short notice. So now we're kind of going through a mindset shift with some of our analysts, say, hey, we're looking at online data now. Sometimes online data is different than offline data, and what kind of information can we make with that? And again, the better we get at that, the more we can automate and put into the software tools and save our analysts for the difficult problems that pop up every now and then. We talked about avoiding downtime and shutdowns with early fault indication. I showed a few examples. There's lots more of those, and again, a lot of them are relatively simple, and it's just a matter of them up early. One analogy I kind of like to use for that of avoiding downtime is, valves are mechanical devices. They fail, and they fail slowly over time generally. Like any other mechanical device, things wear out, build up, they have any number of failure mechanisms, but in almost all cases, it's kind of a slow decay in performance. And an example I'd use is, you take a control valve, and it's out there working, process operators are happy, and then over time the friction goes up a little bit, and some process operator finally notices, hey, this valve's not responding, or this process isn't responding the way it was before, and so they go in and they tune that loop a little bit and bring the performance back up. And then maybe 6 months or a year later, a different operator, different shift notices, hey, that performance is going down again. What's really happening is that friction increased again. Maybe that operator goes in and retunes the loop or retunes the device, kind of puts another Band-Aid on it, and that might happen a handful of times, and then all of a sudden the valve will lock up because the friction gets too high, and it's seen as a sudden valve failure. And I would contend that if you were collecting data along the way and looking at it properly, you might have caught that 6 months or maybe a year before it actually turned into a real problem, and probably could have scheduled maintenance that got it fixed in a much more efficient manner. So there's a lot of opportunities for effective maintenance planning and cost avoidance by looking at the data often, putting it in the right context for an analyst, and acting on it when you can. So some of the things that we've got working on in the near future, just kind of in closing, continuous improvement with our diagnostic accuracy. We started out with it just completely being visual, time series based analytics, but then that's allowed us to real easily start putting in thresholds, alert levels, indications of when things are starting to change. Sometimes it's not crossing a threshold that's important, it's just an indication that something's changed. Valve is operating at X, and now it's at X plus 10%. Is that a big deal? Maybe, maybe not, but the customer and our analysts together can usually determine if that's a problem or not. We are coming up with new algorithms, trying to apply some of the things that we could calculate with offline diagnostics in the past and doing that online, and working on accelerating our analysis. Like I said, when we started out, it was weekly data collection, monthly reporting. We're looking at constantly improving that data collection rate. Can we get down to daily and maybe even faster than daily, just to keep getting more data, and that'll power better analytics, machine learning, other types of things like that down the road. And then we just keep working on different software applications, platforms, whether it's for our analysts or for the end users, and hopefully package that all up in a good IoT solution that makes life a lot easier on our end users here in the near future. I think that's it.